When we're looking at the homework on some of this home function, your problems that you had were on page here. Looking at these. So, seems like from what you said, the biggest problem were the word problems. But let's look at these and see. We picked up with number 48. Did you have any trouble with 48? Now, I need to make sure you understand that because I'm going to give you a big hint. I like that type of problem. It tells me whether or not you're understanding this very well. Okay. Do you think you know what you're doing? Yes, ma'am. Sure, I sure can, and that way you can check it and see what you've got on that. Here are the answers on number 48. You seem to be okay at realizing what that means, right? Alright, and is f at 3, that's saying, is the y value at 3 positive or negative? What was it? Negative, because the y value is below 0. D is f at -1, so when x is -1, is the y positive or negative? It's positive. E, for what numbers is f at x equal to 0? In other words, they're saying, where is y 0? Alright, and when it's asking that, it's asking for your x value. How you write that, you say f at x is equal to 0 when? In other words, this is saying y equals 0. Y equals 0 when? And think where your y is. When is your y 0? When what? Y is 0 when what? X is 0, x is 4, and x equals 6. That's what that means. It says, when is that happening? Alright, when are your y values less than 0? It is equal to 0 at these individual points. F at x or y is less than 0. In other words, let's think of it like this. Y equals 0 is right here. When are your y values less than 0? In this right here, isn't it? And what you do is you're given that when x is from what? 0 to 4. Now, I could have written it like this if I use interval notation, but that kind of looks more like a point. So you might want to put it when x is greater than 0 and less than 4. Why do I not put equal to? What happens at 0? Y is equal to 0, not less than. But you ask about using interval. This is interval, or sometimes if this is an inequality, you might want to have it like that. You can use really either one. Okay, and that was E. Alright, domain. In other words, when do you start having, if you move this across the x-axis, when do you start having a corresponding y value? When you get to -4. For every x value beyond that, you still have a y value till you get to right here. So the domain is from -4 to 6. Does that have a parenthesis or a bracket. Because -4 is part of your domain. Okay, what about your range? What y values have a corresponding x value? It starts at what? A -2 and goes up to a what? Now you're looking for your y values. Your range is your y values. And then the next one, the x-intercepts and y-intercepts. You didn't have much problems with that. Now let's look at K. Yes, sir. And that would make a difference. Alright. But did everybody understand what K was asking you? This is the line y equals, it's asked you y equals -1 is right here. This is the line y equals -1. How many places does it intersect it? 2. How about the line x equals 1? Only 1. And when what x gives you a y value of 3, 5. What value of x does y equal -2? X equals 2. So, does that make sense to you now? Now, I'm going to ask you, all I want you to do right now on this bottom one, I didn't assign all of them to you, but after your homework last night, you should have no problem. I say the number, you say yes or no. Is it a function? Together. 1, 2, 3.
No. Yes. 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 No. No. Yes. Yes.
Alright, y'all know what it is by looking at it, don't you? Do you think about using a vertical line test? I think that is a real good quick visual. So, and I think you can do the same thing on this. Then you had on 61, did you have trouble figuring out what you needed to there? How do I check and see if that point is on the graph? Plug and chug, right? The blades plug it in, little song they used to have. If x is -2, plug it in, find y. And when it asks for a point, remember you write that as an ordered pair. Domain, it's a quadratic equation. Domain is all real numbers. Could you, well, we've done this last chapter, finding x and y intercepts. Okay, on that? C part. If f at x is -1, that's saying if y is -1. So if y is -1, you're going to have this for your quadratic equation. -1 is equal to 2x squared minus x minus 1. And you're going to treat it like a quadratic equation. And first thing you're going to do is set it equal to 0. And that gets you 2x squared minus x equals 0. And then to find your x-intercepts, you're going to factor out your x, set each equal to 0, alright, now what that is saying, this is going to be your x values. That's like, you know, when we did this right here, and you had two answers, and you put y equals -1 across it. That's what they're saying. If y is that. But then this says, what is your x? And then it says, what points? So I know my x-intercept is 0. So I've got to turn that into a point. So the first one, my x, I'm going to replace that with 0. The other x is 1/2. I've got to find my y value. So if x is 0, how do I find my y value? Okay, the function is y is equal to 2x squared minus x minus 1. Or you might have it written as f of x. So to find the y value at 0, I'm going to put f at 0 is equal to and plug it in. I'm going to get a negative 1, aren't I? So that's going to make my y value there. What about f at 1/2? What'd you get? Negative 1. This gets you your 2 points. So there were 2 questions in that problem. If you didn't catch this on your homework, guys, this is what you were looking for on that. 63 was more of the same type of problem. Did you have any trouble with anything on 63?
So the domain, was it all real except 6?
Yes.
Okay.
Domain was all reals except x equals 6. Why would that not be part of your domain? Makes the denominator 0, therefore it's an undefined. So are you okay on 63? Alright, 79. Alright, what was your matching? Now this is thinking about things. The cost of building a house as a function of its square footage. The height of an egg dropped from a 300-foot building as a function of time. The height of a human as a function of time. The demand for Big Macs is a function of price. And the height of a child on a swing is a function of time. So, what was A, the cost of building a house as a function of its square footage? What'd you say? 3. As your footage goes up, your cost goes up. As this keeps going up, this keeps going up. Your cost is based on your square footage. The height of an egg dropped from a 300-foot building is a function of time. We've got some discrepancies here. I think it would be for your, this is the height of the egg, this is your time. At the beginning it's this tall, as time goes on it falls to the ground. And so I think we'll go with that one. The height of a human is a function of time. 1. Alright, mine would have been here and stopped a whole lot quicker, wouldn't it? Because I'm short. But this has to do, you get your adult height and then your height quits rising. It plateaus. The demand for Big Macs is a function of time. It's a function of price. Why?
Because there's always going to be someone, like, who's really rich and loves Big Macs.
Okay. Okay. As your price is getting higher, what's happened to your demand? You priced yourself out of a market. I sure wouldn't pay $50 for a Big Mac. And not many people would, unless, like you said, somebody that was just had more money than they've got since. So, now the height of a child on a swing is a function of time. And doesn't that make sense? They get closer to the ground, they get away from the ground. Closer to the ground, away from the ground. It's a periodic cycle. So that made you think about these, because we got a couple of really cool ones we're going to look at in just a minute. Did you have any trouble with your matching here? Was this any easier or harder? The temperature of a bowl of soup is a function of time. Which one is that? 2. It's kind of like the price. As time gets more, the temperature is going down. It's inverse. The number of hours of daylight per day over a 2-year period.
5.
Yes, you've got to realize the significance of that when it says a 2-year period. And it's like you said, that's going to be the significance. Because if you look at it, the number of hours of daylight, it's, as your time's going on, it's a lot. Winter it goes to less, summer back up to more, winter to less, and summer to more. You have to look at that 2-year period. The population in Florida is a function of time. I think it's 4. You think the population has grown? As time has gone on, it's gradually gotten higher. Florida's become a lot of people retire there now that didn't used to. And that's been one of the key things about their population. The distance of a car traveling at a constant velocity is a function of time. 3. If it's going at a constant rate, that means you've got your cruise control set and you've got a wide open highway and no stop signs. As the time gets more, the distance is getting higher. The height of a golf ball hit with a 7-iron is a function of time. Alright, and this should apply to number 91. Did you even think that was planting in your mind the concept of the path of a golf ball? What is the shape going to be? A parabola. You got it, girl. Now let's look at 84. Now I hesitate. I just don't know if any of you all fully appreciated Michael's day. You know, every function tells a story. And Michael's story in number 84 is far more interesting than you realize when you first look at this. This is a function of time. This is what happened to Michael. Just concentrate on the pool board.
In 9 minutes.
Yes. Wow. What happened is, boof! His alarm went off. He had to be at school in 10 minutes. Jumps in the car, pushes the gas. What happens here?
Stop running.
No, he keeps going for a while.
Cop car.
Oh.
Oh. So he cuts the speed to 30. You see, rapidly speeds, goes to 30. And what happens right here?
Pulled over.
No. A dog runs in front of him. He almost hits a puppy dog. Tragic. What does he do? Slams on the brakes. Look at that rapid decline in speed. And he's sitting there right there just trying to catch his breath. He's about to have cardiac arrest. He almost hits a puppy dog. Then what happens right here? Oh, he looks at the watch and realizes, oh, I have already used up 6 out of my 10 minutes and I'm not at school. Guns it. Alright. Slows down here. He realizes it's 45 and he's already at 50. Slows down. Sees another cop car. Slows down rapidly. Coast at 38 miles an hour until what happens right here? Pulls into the parking lot. And stops. And he has got 9/10 of a minute to get to his classroom and not be tardy. Did you not see it when you read the problem?
I'm glad we recorded that. We can go back and watch it again.
Thank you, Samuel. We'll make Alex's day, won't we?
Yeah.
I mean, every graph is going to tell you a story. May not be quite that graphic, but you see what happens. See what that's representing. It represents something. Now, after that, did you have any trouble answering your questions? Should that make them even more entertaining? Over what interval is he traveling the fastest? Now, remember, your interval is talking about your time here. Okay. Now, his speed is constant between 2 and 4, between 4.2 and 6, between 7 and 7.4, between 7.6 and 8. Those are where it's constant. Alright? Constant means basically when the slope is 0.
So it's not just like the longest one?
And you list it as an interval, and each one of them would be listed separately. So, over what interval is his speed 0? From 4.2 to 6. And the interval is going to be your y value, or your time, because that is your time. What is Michael's speed between 2 and 4 minutes? 30 miles an hour. Between 4.2 and 6, it's 0. Between 7 and 7.4, it's 50. When is his constant? His constant is between 2 and 4. Alright, how do I write that? I don't know what it'll have it. Am I going to use brackets or am I going to use parentheses is what I'm asking you. At 2 minutes, 2 minutes is when he gets there. So actually, because it says between 2 and 4, between is not necessarily included. It would have to have the word inclusive to be included. It's also constant between 4.2 and 6. It's constant between 7 and 7.4. And it's constant between 7.6 and 8. It's constant in each of those intervals. Now the book puts the word between, but I wanted to do it like this, just to let you see. It doesn't say it includes that. It's getting there at 2 minutes and then levels off. So those were your constant times. Alrighty. Now 91 is the one you had a question about, right? Looking back at the one earlier, first thing I need you to do is figure out if you're doing, this is the function, the height of the golf ball is a function of time. I mean, it's the distance it goes. The height and this is your horizontal distance. So if it's gone this far, what would be the height? Now guys, what is going to be the path of that golf ball? What will it look like? It's going to be a parabola. What goes up is going to come down in the form of a golf ball. Alright? So this is going to be the parabola. When we look at our function, h of x is equal to negative 32 x squared over 130 squared plus x. This is our function. To determine the height of the golf ball after it's traveled 100 feet. I'm going to show you something in your calculators I did not get to show you the other day. Alright? So get out your calculators and let me show you a couple of things I want you to know. The first thing we're going to do, because you need to know how to do it, is we're going to get the window of this. Alright? Turn it on, goes to y equals, clear out anything you've got there, and put in this function. Now here comes the interesting thing about entering this function. How are you going to do it? Okay. Okay. How could you do this? Could you make it look any more like a quadratic equation?
I mean,
In other words, can I write this as my coefficient? Could I put negative 32 over 130 squared, x squared? Do you ever think about doing that? Or would I have to do it this way? Does it make any difference?
no.
Okay, so I'm going to do mine like this then, since it doesn't make any difference. Let's find out. And graph it. That doesn't look at all like this parabola, does it? Why?
Wait. Which one did you put in? I don't know. I mean, the only thing I just now, I put is the negative outside of the parentheses, and I got.
Does it look like that on a normal screen though?
It looks like this, which is weird because when I graphed it yesterday, it was like off the screen. Oh wait, no, I had my window like in the window.
Ah, that's my question. My window, you can't see the whole thing, can you? No. So I'm going to have to do some big adjusting. I'm going to change my window. Now let's keep in mind, it's like this is your graph. I'm only needing basically this quadrant over here, aren't I? Because we're going to be starting at 0, 0. You can't have a negative height or negative length. So I'm going to have to work on this. My x minimum, I don't really need anything except I'm just going to put a negative 5 because I just need a little bit. X max is going to be how far out this baby goes. I'm going to put 200. I might hit it 200 feet, so I have a good day. My y min, I'm going to put it at a negative 5. My y max is how high this thing goes. I'm going to put it at 150. I'm doing something just to try to gather in. Okay, do I get my... Well, I hit that thing further than I thought I did. You know, I'm pretty good at this game. Alright.
1,000.
Yours is at 1,000? Now I need to change my y max. She's got it at 1,000. Okay. I'm going to do just 650 to keep it even. Alright, and I've got it all in there, haven't I? I'm able to see it. So this is one thing I wanted you to make sure. You've got to make sure that you have got your complete window in there. You've got to be able to see your x-intercepts. You've got to see your maximums or minimums. This is your complete graph. Now, it asks you on number B, It says, what is the height after it's traveled 300 feet? The height is my y, isn't it? Isn't it? Let me show you a little trick. I have put this function's in y1, isn't it? So let's get out of there. Second, quit and get out. You see this bars button? Stands for press bars. Go over to Y bars. See where it says function? Okay, hit enter to choose that. Now you choose which one of these you put it in. I put it in Y1, so I'm going to choose Y1. I'm going to put a parenthesis. Now I'm going to put 100. That is evaluating that as 100. That's the same thing as putting 100 in place of my X. Oh, yeah. Boatload of time saved. So that tells me that when I come out 81 feet here, 81.07, it is 100 feet high. Not doing anything. Okay, we're going to do another one. The second one says, what is the height after it's traveled 500 feet? I'll show you a shortcut and then I'll go back all the way through. Well, I'll show it this way. If I want to find it, I go vars. Now, y'all be trying this. So remember how to vars, Y vars, enter for function, choose Y1, do a parenthesis. You want to find it after 500. Now let me ask you something. Have I put my graph wrong? You all are just sitting there listening to me. What am I? This is my X value. See, you let me put this here and nobody caught what I was saying. You've got to realize which one is which. This is what's going in place of your X. So this is saying when I've gone 500 feet, my Y value is 26. So here it was 181. Now my graph doesn't look at all, it's not at all proportional, but you see what I'm saying? What if I wanted to evaluate at 300? Let me show you another shortcut. Everybody look up here. If I want to evaluate it at 300, the same function, I hit second, enter. That brings it up exactly what I'd done before. I simply go back and change that to 300. When it's 300 feet out, it's 129 feet in the air. Guys, if you've got a big old function, this sure does help. Isn't that easier than plugging those numbers in place of X? Is there any other way I could have done this? You could go to your table. What if I did this second calc? Can I use anything there to do the same thing? No. What about just value? If I let X be 100, doesn't that give me my Y? That's another way to do the same thing. These are some keystrokes that are really, really helpful. Okay? So we've got B and C. We've graphed it. With D. Now, E says to algebraically determine the distance that the ball has traveled when the height is 90 feet. What am I going to do with that height then? Where does it go? Right here, so I've got 90 is equal to negative 32 over 130 squared, x squared plus x. Alright, babies, how in the world am I going to solve that for x? What do we have? We have a quadratic equation. I've got an x squared. How do you solve a quadratic equation? Quadratic formula or factor, and this one won't factor. So before you use the quadratic formula, what are you going to have to do? Set it equal to 0, so you're going to have negative 32 over 130 squared, x squared, plus x minus 90 equals 0. So A is negative 32 over 130 squared. B is 1 and C is negative 90. You have to put that in your quadratic formula. Now you all remember the quadratic formula, right? Remember? To the tune of Adele's Rolling in the Deep. Yeah, that'd be fine. Be fine. Alright, now I'm going to go ahead and show you this. It's worked out here using your quadratic formula. Messy, but doable. So look at that way it's worked. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You should get the same answer if you did it that way. Multiplied through by that because I worked it that way one time to make sure. And just go ahead and get that figured out. Why am I getting two answers? Alright, it's a parabola. I'm saying when my height is 90 feet. When my height is 90, am I not going to have two x values? Yeah. So, do you see what that's saying? So, it reached a height of 90 twice. The first time when it's gone 115 feet, and the next time when it's gone 413 feet. Do you see what that's saying? Not saying are you really looking forward to problems with that much of a hassle, but do you understand? You're just using your basic quadratic formula. It just got messy because your numbers were big. Now,
messed up if you mess up the sum, because I put a negative x instead of a negative 90.
yeah. You've got to be really little things like that, and you get into it and it just gets messier and messier and messier. And after a while you can't see where you got messed up or anything because it's just so messy. Now let's look at using your calculator to do something else. On number S it says create a table. The table starts 0 and the difference in the table being 25. This is kind of like, again, kind of like zeroing in on using a camera lens. I'm going to go to my table. Guys, that is to try to find my maximum. Scroll through here and find the maximum height. That's going to take a while, isn't it? I can do this. Go second, table set, if you've never done this. I'm going to have it starting at 0. But the increments of the table, I'm going to put on 25.
Morning, GHS. At this.
Alright, when you do that, now hit second table. And look at this. You're jumping by 25. So as I go down, remember this is our height right over here. What's happening to our height? going up. But isn't it easier to do it this way than to have to go by so many? Height's still increasing, still increasing, still increasing. What's happened? Got a gap there, don't we? So it looks like somewhere around 275 was the height. It could have gone this way, but I don't believe it would have gone this way, right? So, someplace in this region. Now, here's what we're going to do. We're going to zero on a little bit more. We said about 175. Go back to second. Table set. Had it beginning at 175. Let's let our increments now just be 1. Because that got us in the right vicinity. Hit our second table.
I think it was 275.
Okay, so let's go in and check our tables. Set 275. Alright. Second table. Now look at this. Is that letting you really get close in about it a little bit more? Well, at 275, it's 138. Let's see what happens. Oh, it's even higher before that. At 268, it's 132. It has already started going down at 275. Still going up, isn't it? So looks right like from 263, 264, 265. Right in that was your highest. Right? Probably it's going there, that, yeah. So I would say that 264 is where it was the highest. And the highest was 132.03. So we got our maximum. Okay, now what about our domain? It starts at 0. Our domain is going to be whatever the value is here when it hits the ground again. And how are we going to find that value? At that value, y is 0, isn't it? And we need to find x. That actually is a 0, isn't it? So, let's go back to our function. Second calculate, and we're going to be calculating a 0. Now, I believe on this one, our left bound is going to be, I'm going to use my cursor on this one. My y is positive there. I'm going to let that be my left bound. I'm going to use my cursor. If I get a negative number, that means it's gone past it. I'm going to let that be my right bound. I don't want to guess. I want to know. At 528.125. That's where it hits the ground again. So the domain is from 0 to 528.125. What am I going to put on that? Brackets or parentheses? Okay. If I did it like that, but in set builder, the domain x is greater than or equal to 0, less than or equal to 528.125. Does this make sense, I guess, now is my question. Number 91 made you think. Now, if this was set builder, like Autumn said, I would have this, set of x, such that, and that on the end of that. So, depending on what we ask for.
How do you know when to put it in that? Will it specifically say? Because, like, I think I had the domain in the brackets, but then I looked in the back of the book to check, and it had it as the set.
Okay. it means the same thing unless it specifies you actually can use either one. If I want it in a specific notation, I'll put that in. Okay, otherwise I'll accept either one. Alrighty, so, do you think that made you think a little bit? Alright, good deal. May give you a little quiz on 2-1 tomorrow, so just as a heads up. Now, linear functions and models in section 2. This is basically, do you know how to do a scatter plot in your calculator and get your line of best fit? Alright, let's start right here with this one. Get your calculator out. I'm going to eliminate what I've got in Y1 because I'm going to show you how to use that in just a minute. If you're going to do a scatter plot, you go to Stats and Edit and put your information in. Now listen to me. If you've got something in this list and you want to clear the whole list, you go up to the top of the list and press Clear. Come back down and it'll be gone. Under no circumstances do you press Delete, because you delete the whole column. You just want to clear the column out. Okay? Now, in list 1, put all of your X values. Okay, enter that right now. 0, enter, and then you go 10, 20, 30, 40. Whoops, I made a mistake, so you just go back and re-enter it. So you've got those in. Now go over to L2 and put these in for your Y value. Alright, so everybody got them in? To see, they've got it on the next page, they've got it as a scatter plot. To make a scatter plot on your calculator, you get out of here, go Second, Stat Plot. And in here you've got your stat plots. Let's choose the first one. It's off. I want to turn it on. And then you come down here to the top. This is a scatter plot, linear. This is just graphing with like that. Here's your box and whiskers. You've got different kinds of graphs you can put in here. But we're going to choose that. Okay? We know our X's are in L1 and your Y's are in L2. I've got this set up to graph it. So I get out of that. Now to graph it, go to Zoom, go down to number 9, which is Zoom Stat. With me, Samuel?
Yes, ma'am.
Okay. And look at that. I've got that stat plot graph. Now, if I look at that and I can see that's pretty much a linear pattern, isn't it? So I'm going to go and I'm going to get it figured out. So I'm going to go Stat over to Calculate. And I'm going to get the linear function that represents that. So I'm going to go down to linear regression. I'm going to press enter. And it says X is in L1, Y is in L2. I've got that right. Now right here, guys, pay attention to this. I'm going to store that regression. So if I want to go back and evaluate, I don't have to do it by hand. I don't have to rewrite it. It just makes life easy. That's why I cleared out anything in my Y1. I'm going to store that in Y1. And I'm going to do that by going vars, y-vars, functions, y1, and see I have stored it in y1. Go down to calculate and press enter. This gives me my linear regression. This is my slope. This is my y-intercept. Okay? Now when I go to y1, lo and behold, I've got that very same thing there. It's long, it's got all the decimals and stuff, but I've got it there. So that's how you put that in your calculator. This also makes it easier if you get a linear regression and you're trying to predict something. Now what we've got here is the relative humidity if this relative humidity is this, that means the apparent temperature is that. Well, what if I wanted to evaluate if the relative humidity was something that is not on this chart, like 35? Do you remember what I showed you earlier? Vars, y-vars, function, choose y1, and I evaluated at 35. No, you just go back to stat and you see that that's basically you have put in just the numbers you're given. Now if I went back to this equation and I put table, I could get a table from that equation.
And it would be the same as doing the other way?
But you would have to have all the numbers in here. And it might be a number that, since this is so big, if I went back on this down to, I evaluated 35. See, that's what at 35 had it at that, and that's what I'd gotten by doing the other way. This is evaluating what would happen at stuff in between that. At 36, you could expect that. So that would get you the same thing. Yes. Good question, Amber. Alrighty, now do you see how to do this? In case you didn't remember. Okay, read through here. This is a direct variation. Like if you got y equals 2x, that's like the equation y equals 2x plus 0. To graph it, you know you got an x 0, you can graph it like that. 0 the slope of 2 over 1 and graph it. It also shows how to use that when you are borrowing money. And that's pretty much what's in this. Now you have your assignment sheet. So you can go back and work on these for tomorrow. Any questions?